So this is a Leaving Cert past paper question from 2018. It's paper 2, question 5. It's on coordinate geometry of the line. So we have a line which is parallel to another line. Verify that a point is on one of the lines. So A is on M. So what that means is if A is on M, then you can substitute the x value of A and the y value of A into M, and the equation should hold true. So twice the x value of A, which is minus 2, plus 3 times the y value of A, which is 1, plus 1, that should equal 0. So twice minus 2 is minus 4, plus 3 is minus 1, plus 1, that does equal to 0. Okay, so that is true there. Find the coordinates of B, which is the point on the line N closest to A. So here we're basically looking for that point which is on the line N, but it's also on the line that is perpendicular to N, which is the line AB. So if I know the equation of N, which I do from the first question, if I find out the equation of AB, then the point B will be the point of intersection between N and AB. So I can just use simultaneous equations. I'm going to try and find the equation of AB, and I can do that because it's perpendicular to M, so the slope will be perpendicular to N, and I already have a point on the line AB. I've got the point A. So first thing we need to do is find the slope of N. Slope of N is going to be, well, if I just use some rough work here at the side, this is the equation of N, 2x plus 3y minus 51 equals 0. If I rearrange that equation and isolate y, 3y equals minus 2x plus 51, y equals minus 2/3 of x plus 51 over 3, which is 17. Well, when I rearrange the equation of the line into the form y equals mx plus c, that number in front of x, so the coefficient of x, is the slope of the line. So the slope of the line n is actually just minus 2/3. And I know that if you've got a perpendicular line, then m1 by m2 is equal to minus 1. That means that the slope of AB, it's going to be minus the reciprocal of the slope of n. So it's going to be minus that slope, so it's going to be minus 2/3, which is plus 2/3, and then it's going to be the reciprocal, so you just flip the fraction. It's going to be 3 over 2. And the reason that is because minus 2/3 multiplied by 3 over 2 is equal to minus 1. So the slope of AB is 2/3. I know a point on AB is A, which is minus 2, 1. So therefore, y minus y1 equals m times x minus x1, which is my equation of the line. So y minus the y value of A, which is 1, is equal to 3 over 2 times x minus the x value of A, which is x minus minus 2, which is plus 2. So I'm just going to write that in a standard form for a simultaneous equation. Multiply everything by 2. 2y minus 2 equals 3x plus 6. And I'm just going to rearrange that. 3x minus 2y equals minus 8. So that is the equation of AB, and the point of intersection B is going to be found by using simultaneous equations between that and the line N, which is 2x plus 3y equals 51. Okay, so slightly awkward one here. We can multiply that by 3 and multiply that by 2. And I'll just continue it here. You've got 3 times x, which is 9x, minus 6y equals minus 24. And I multiply the second line there by 2. I'm left with 4x plus 6y equals 102. If I add them together, I have 13x is equal to 78. So x equals 6. And then I can just substitute that into either equation. If x is equal to 6, six times 2 is 12, 3y is equal to 39, y is equal to 13. So the point of intersection B is 6, 13. So we'll just have a look at the next question then. So in this question, I'm asked to find the equation of S, the circle. So what I'll need to do is I'll need to find out the center and the radius of S, and then I can just plug it into the general equation of a circle. You're told that I'm going from A to B, the radius of S compared to the radius of T is a ratio of 1 to 3. So I'm going to first just start by getting the ruler out and drawing that line there. I'm going to mark in the center here and here. Okay, so it's a ratio of 1 to 3. So if that was 1, that would be 3. So I've divided up that line segment there from A to B into smaller parts. In total, I've got 8 proportions. I know that the center of A was given in the original question, which is -2, 1. And I know that B from the previous question was 6, 13, that had worked out. Dividing lines and line segments and things like that, you can use the tables and use the formula, or else actually you can just use the translation. So what's happening here is I'm going from A to B. Let's have a look and see what's happening to our x values. X is going up by 8, and y is going up by 12. So that is going from A to B, but I only need to go to the center there of the circle S. So in the rough work here, I might just add that A to the center of S, okay, it's actually only going to be 1/8 of A to B. Therefore, the center of S for X, it's going to be -2 plus, we're only going to up 1/8 of 8, because the center there to A is only 1 radius away, which is 1/8 of the total distance from A to B. So that's going to be -2 plus 1, which is -1. And the y coordinate is going to be 1 plus 1/8 of a jump of 12, which is 1 plus 12 over 8, or 1 plus 3 over 2, 1.5. So that's going to be 2.5. So therefore the center of S is going to be -1, 2.5. And the radius is 1/8 of the distance between A and B. The distance formula from the tables is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So plugging in those numbers, we're going to have 1/8 of the difference between the x's, 6 minus -2, which is +2 squared, plus 13 minus 1 squared. Okay, so in total that is 1/8 of 8 squared is 64, 12 squared is 144. That is going to be 1/8 of the square root of 208. That is going to be root 16 by root 13, which is 4 over 8, so it's root 13 over 2. So for the equation of a circle, we can go with this formula up the top for the equation of a circle with the centre hk, radius or. We've got x minus h squared plus y minus k squared is equal to r squared. So the equation of S is going to be x minus h, which is the x coordinate of the centre. So that's x minus minus 1, so x plus 1 squared plus y minus 2.5 squared is equal to the radius squared, which is 13 over 4. Because root 13 by root 13 is 13 and 2 by 2 is 4. That's coordinate geometry of the line and the circle in that question.